So yeah, so someone just asked the question, do we have to use Eclipse to write assignments? No, because you can use anything you want. It's a, because you'll be submitting a text file with the extension JAVA. And when I first started teaching Java at this school, it was actually 2004. Um, we used Notepad. It's just hard to believe. I'm not even sure I would know how to do that anymore. I've regressed, students. So right now you should be, and I post these online. I think there's a folder on Canvas called like Java review files or something, and this is under array. So this is really basic information. I'm just going to run through this pretty fast, though. Don't hesitate to ask a question, and then I'm going to. Then the main topic is, or the new materials and methods. The file called methods and arrays. I didn't create a module yet, but so this is all, it's all under files. So here we go. So array is one of our favorite topics in Math 130. Okay, so hopefully well, again, this is what I talked about Math 130, but so we're just going to talk about, basically how to declare an array, all the really basic stuff about arrays. And so why do we have arrays is because we don't want to declare lots of variables. Let's say we have a variable, we're analyzing like a grade program, and we have 3 grades in a course. Okay, so you have these 3 variables, 1, 2, and 3, grade 1, 2, and 3. But let's say you want to then, now you want to have change your grading scheme. You have 6 grades, 6 exams. You add on 3 more. So you have to edit your code and declare 3 more variables. Or God, what if you have like 10 exams? That's a lot. Or you have like 20 quizzes. Or you reduce it. So you don't want to have to edit your code constantly. You don't want to have to do a lot of editing. So arrays kind of limits the amount of editing we have to do, or maybe totally eliminate it. And so if we have a variable, let's say we have a collection of data that's all kind of the same type. So we can use arrays to store this information. So an array is just a variable that stores a fixed number of values of a single type. And the number of values in the array is the array length. And you might remember that the array length is fixed. And so let's look at just an example on the next page. Okay, so this is one way to declare an array. And usually you declare the array and allocate memory in the same line, but it doesn't have to be. But the one thing we know is, how do you know exams is an array? What's special about that statement? So right now you should see slide 6, an example of declaring and allocating memory. And so the first time you see a variable declared, you look to the left, and it tells you everything you want to know about that variable. So we look to the left, and what we see int and then the square bracket. And so that square bracket is how we know we're working with an array. Okay, so an exams is a variable that points to the first of a list of integers. But right now it doesn't, we haven't actually allocated memory. Okay, so all data is stored in the computer's memory, and the basic unit of memory is a byte. And you have to know this. And you talk more about bytes and addresses in Math 230, but every byte in your computer is identified by an address, just like our homes have addresses. Okay, so so in the next line, we go exams, is assigned new int 5. So that thing that looks like an equal is really an assignment operator. And we always start on the right side of an assignment operator. And so, so we see new int 5. That means allocate memory for an array of length 5, 5 elements. And it's being assigned to exams. So what's exactly being assigned to exams is an address where we can find the array. So maybe the first element of the array is stored at address 1024, which is actually way too small. The addresses are actually huge numbers, but whatever. Okay, so what's actually stored in the variable exams is not actually the data stored in the array, but the address where we can find the data. Okay, so some of this is just stuff that I've just said. Okay, so when you just see the variable declared like that, just int exams by itself, exams doesn't have a value. We haven't assigned it memory. And then the next statement actually assigns it memory. And we assigned it, and an array has a fixed number of values. So in this case, it has 5 values and it's fixed. It doesn't change length. So if we can assign a new array to exams, but then that's going to have new be assigned in a new memory location. So, okay, so so the values are stored in array elements, and we need indices to refer to the individual elements. And so computer scientists, for some reason, like to start counting from 0. So the first array element is at index 0, and the last one is at index, it's always the length of the array minus 1. So in our example, the array had 5 values. So the last index is index 4. The length is 5, but the last index is 4. So here's one simple way. So the point of this slide is that every array element is actually just an integer variable. So we have 5 integer variables denoted by exam 0. We're using like an index, or if maybe you've seen sequences in math, it's kind of like like a subscript. Exam 0, exams 1, exams 2, and they're all assigned their own value. And again, the first index is 0. Because the array has 5 elements, the first index is 0 and the last index is 4. So it's length minus 1. Okay, so students, so now this is perfectly okay. This doesn't have any compiler errors. Remember, compiler error is compiler is kind of like a sophisticated word processor. It looks at our code, looks at the code in our Java files, and sees if there are any mistakes in it. And if there are, then maybe we forgot a semicolon or something like that. And there's a red dot, and hopefully we get a reasonable error message, which a lot of times we don't. Sometimes it's kind of hard to figure out what the error message is. But if there are no red dots, then you can actually run the code. Now, the fact that you can run the code doesn't mean your code's going to work. There might still be logical errors in your code. So here's an example of logical error. So we said that exams is an array with 5 elements. So in each case, the index is out of bounds, and the compiler doesn't check that. If you type that into into Eclipse or NetBeans or whatever it is that you're using, it won't flag it. You won't get the red dot. But when you run it, you'll get an error, array index out of bounds exception, in which probably everybody, including me, gets all the time. So -1, it can't be negative, right? The smallest index is 0. And for our particular problem, the greatest index is 4. So exams of 5, well, that's an index out of bounds error. Exams 100, that's also index out of bounds error. And usually compiler errors are easier to fix because you're being told exactly where it is. So, you got this red dot. Hey, the problem's right here. Where index, runtime errors. Well, you'll see where the code crashed, but sometimes the logical error is really somewhere else in your code. And usually, the longer your program is, the harder it is to find the runtime error. I know there have been studies done. Trying to how long it takes to find a runtime error depending on the length of the code. But it's always better to get a compiler error than a runtime error. Not always, but probably in most cases, I'd say. Now, students, you don't actually have to declare an array and allocate memory in separate lines. Typically, it's more like that example 1. We have this array called AVE, and in this case, it's a list of doubles. So you look at av, and you look directly to the left, and you see double square brackets. And so that, the square bracket means list or an array. AVE, it refers to a list of doubles. And in this case, it's going to be a list of 30. So in this case, we're declaring the array variable and allocating memory in the same line. And that's probably more the norm. But you could do it in separate lines, like we have there in example 2. Oh, so students, Java allows us. See how you have there on slide 13, you can declare the square brackets after see here in square. It's more like, I have the example right here. So there I'm going int ARR square brackets. That Java doesn't, that's not a compiler error. Though I think you hardly ever see that. And I think, I don't know if it's, I'm discouraging you. When I say it's discouraged by me, I guess. So, but I hardly ever see it. I think maybe they do that
Okay.
in C, maybe that's why they allow it. But, I think the norm is to, the norm is to put the square brackets after the data type.
I have a
So,
question real quick.
yeah, go ahead.
Um, could you even put it before the int? Just out of
I don't
curiosity.
think so. I don't think you can.
Okay, so it has to be at least after the int or after the name.
I believe it. Yeah, I have never seen it before. So, and sometimes is it okay to, sometimes I just try it and see. Okay, I might get, I am assuming that the answer is no. We can try it. When I open up Eclipse, we'll try it, okay? But my guess is the answer is no. I thought it was always, I think it's always the square bracket is after the data type or after the variable. So we'll see, and we'll try it out in a minute. But any other questions right now? Okay, let's continue. We're almost done with this. The real interesting stuff is the real exciting stuff is coming up. So okay, so students, here's just some things that maybe let's just review this and make our life a little bit easier. Okay, if we know this stuff. So slide 14. So we see ARR is an array of for every when we declare an array, when we allocate memory for an array, every array element has a value. And so if you declare here we're declaring an array of integers. In this case, ARR has 3 integers on slide 14. So if it's numeric, the default value is 0. And if it's an array of doubles, it would be 0.0. So, but you can actually, there's a way of kind of initializing values. Let's say you have a short array, in this case, like just 5. I do this all the time. You have an array with this, let's say like 5 elements. You can actually hard code the values when you declare the array. So in this case, scores, see on the right side of that, on slide 15, okay, you're going in square brackets scores. Then there's the assignment operator. So remember, you always start on the right side of an assignment operator, and it looks like set notation, like 11, 34, 45. So that set has 5 integer values in it. So in this case, scores would be an array of length 5, and the scores of 0 will be 11, scores of 1 would be 34, and so forth. Again, if you printed out all the values, that's what you'd see: 11, 34, 45, 1, 100. This is good. I do this a lot. Sometimes I write the main method when I'm giving an assignment. I write the main method and I'll initialize my arrays this way because it's often a lot faster for me. Is there anything else? Oh, the famous length property. So this is something you definitely want to memorize if you've forgotten. So length, no parentheses. So let's say we have this array. The name of the array is list. And you always know the number of elements in an array by going like array name dot length. See, in this case, there's like on slide 17, there are no parentheses. It's in this case, length is a property of an array. It's more like an instance variable. It's a property of array. It's not a method. So in this case, list dot length is 10, right? Because we declared a list with 10 values. And you can always, so because of that length property, we can always immediately access the very last element of array. Well, the first element is always 0, and the last element is always array length minus 1. Okay, so let's say the name of the array is list. So especially if you're first learning Java, I think that assigning a value to the last array element, maybe it's kind of daunting. In this case, it's list, and then you have the square brackets. And then inside the square brackets, you have list dot length minus 1. But we don't, so this way we don't have to know, but let's say we write the code and we change the length, or you don't actually have to know the length to actually access the very last element. So it's always length minus 1. Okay, so what happened here? Okay, so it can get a little confusing, especially if you're first learning Java, because there's all these different ways of measuring things. So the string, there's this variable type called string, and we know something's a string. It's a double quotes, with a bunch of characters surrounded by double quotes. Like in that case, house. There on slide 19. And now, how do you get the length of a string? Now, length is actually a method. See, string, see it's spelled, the data type is uppercase S. So when you see uppercase, that means it's actually an object, right? So, but you probably learned how to write your own, you wrote, hopefully in the last few weeks of Math 130, you wrote classes and created your own, declared variables, objects based on the classes you wrote.
Professor,
Yeah, go ahead.
I have a question about strings. I remember from Math 130 for every primitive type, there was a wrapper class, but I can't remember if there was a wrapper class for the string type or not.
No, there's no, the thing is, the wrapper classes are for the primitive types. So like for every primitive type, like there's int, and then there's the corresponding wrapper class integer. And you actually spell out the word integer. And so one is actually like a primitive type. Here's the difference of primitive types. Let's say, this is why I might do this when I open up Eclipse. Tell you what, let me get back to your question when I open up Eclipse, okay? I think I
Yeah,
can
no
give
problem.
then I can start typing some stuff instead of just saying it. But no, there's no corresponding string. Is kind of, it's like a wrapper class, because do you see how a string is it's actually a class, and it has some special properties. And the special property is this first line right here. When you go string str, that is assigned house, we're not actually calling the constructor. And so the string class has that. So we can actually assign a value. We can actually create a string object without actually calling the constructor. So that's why it's kind of like it's similar to a wrapper class in that way. But it's not, but there's no course, because we don't have a primitive type that string, it's not really a wrapper class. But yeah, we'll get back to I'll talk about the wrapper classes when we open up Eclipse. So like car, actually, see that car is like a primitive type, and it has a corresponding wrapper class called, and I think it's actually spelled the whole thing out, character. So which probably most people never use. Okay. So but any other questions? Okay, so where was it? Okay, so string is actually an object, and you get this, we don't write it ourselves. When we install the Java development kit, there's actually a file that's installed on our computer, string.java, and you don't see it, it's compressed. But it's actually a class of all kinds of methods. It's just like, we write our own user-defined classes. This, somewhere, I think the Oracle people, at least are maintaining this file. And there's actually a method called length. So when you want to find the number of characters in a string, you go, string variable name dot length, but now you're using parentheses because we're calling a method. Whereas for an array, we're actually accessing a property. It's more like an instance variable. And then there's another one, which you probably talked about, array list. And to get the number of elements in an array list, you use a method called size. So there's all these different ways of measuring the number of elements in one of these objects, and you just have to memorize. I can see how it can get confusing if you're new to this, but you just have to memorize it. Really, you do it. You just work with it enough. It becomes kind of second nature. Okay, so I think this is the last thing I'm going to say. Typically, arrays and for loops go together, yeah, okay, so you probably have seen this a lot. You want to access every element array. You want to assign every element, the value 1. So usually you initialize the counter variable at 0. And the common Boolean expression, in this case, the array name is numbers, and the counter variable is k. The common variable, the Boolean expression would be k less than numbers dot length. So as long as that Boolean expression is true, you do another iteration of the for loop. And when k is actually equal to numbers dot length, well then if k is, let's say like k is 1,000, 1,000 less than 1,000 is false, and then we'd stop. The loop would stop. And then usually you go increments of 1, but you don't have to. I think that's all I want to. Oh, this is something I use Zybook, so I didn't. Yeah, the Zybook for some reason they did I don't know why they do it this way, but we don't care about this. I probably could have eliminated this. Okay. So this is it for the introduction. I'm going to talk about that. It's the next set of slides that might be vaguely interesting. So hopefully this is all review, but if not, don't hesitate to ask questions. Any questions right now? Okay, I did want to say something about there's no book. I forgot to talk about that. So there's no book for this course. I never used to, when I taught in the olden days when I taught in the classroom, seems like a long time ago. Yeah, it doesn't, yeah, so what is this, February? It's been almost a year. And yeah, they told us 2 weeks, and so a very long 2 weeks. Um, so what does that say? Oh, I never used a book in Math 140. I'll post a link to I take some of the material comes from a book called Algorithms by Cedric. I'll put the link online. Hopefully the notes and any kind of videos, and I'll post notes and videos, and hopefully all that will help. I wasn't really crazy about the Zybook for Math 140. Some of it was unusable to me. Some of it was actually pretty good. But I don't know. I didn't really, I didn't think it was worth the money, to be honest. Okay, so are people talking to me? Are you talking? Okay, so good night. No Zybooks, no. And then, and I thought the Zybook for Math for 130 was okay. It wasn't perfect. I think the first 5 units I thought were great. The middle units were okay. And the last units I thought were missing a lot of stuff. So anyway, yeah, so no Zybook here. I think I can provide you everything you need. I didn't really think there aren't as many online exercises as there were in the Math 130s. I don't know. So I'm going to switch over to the next set of slides, and I think I can just tab this. So can we go to methods and arrays? And this is all like, look at that. I'm actually doing something right. I'm so bad at Zoom. I don't know. So methods and arrays. So this is normally what I talk about in the first lecture of Math 140 in the classroom. And I am doing a lot more talking than I would normally do. So if we were actually in a classroom, I would lecture for a little while. And then maybe I would ask you to do some problems, and then students would walk to the board, and I'd walk around the room and kind of plead with someone to go write their solution on the board, and then we would discuss it as a class. So, but we're probably not going to do that. We're not going to do that here. So, no, probably we won't. Okay, well, no board, first of all. So, okay, so anyway, so methods and arrays. So, and there's also something about the null keyword. And then we're going to open up Eclipse. I'll talk a little bit about before, and I'll start by going back to the wrapper class, and then we'll do a couple of examples with Eclipse. And again, nothing special about Eclipse. It's just what I use. So let's see what I'm trying. Okay, so we're going to write methods, and so in our methods, and so Math 140, our methods will have one return statement and no break statement. So and I'll show you how to do it. It's really not too bad. And so we're going to write well, first of all, where's my pointer? Where's my cursor here? I feel like the cursor has been lost. Do I have to do it with my finger? Oh, that's sad. Okay, so hopefully this kind of concerns me. Hopefully, I hope that's not a problem when I want to use Eclipse. Okay, so anyway, okay, so yeah, because right now I have to scroll without, I can't use my cursor. I don't know what happened. So, okay, so, see, something had to happen. Nothing goes smoothly, I'm telling you. So, okay, so first let's talk about the null value, which is really not about methods. So null is actually a keyword, meaning we can't use it as a variable name. It satisfies all the rules, so it's all alphabetic characters. And so variable names can be, alphabetic, underscore, and $sign. Oh, and numeric, except it can't start with numeric. But and then there's this null keyword. So we'll be seeing that sometimes. Let's just talk about that before we talk about methods and arrays. Okay, so let's do, so what I said before, string is actually an object. So the primitive, so objects, and just like arrays, what's actually assigned to an object variable is a memory address. So the string variable doesn't actually contain the contents of the object. It tells us where we can find the object in memory. So, okay, so like that, so that example 1, str is assigned cat. Okay, so let's say str in this case, we never really know what the address is that it's been assigned. Okay, but let's say str is assigned address, again, I'm making up some small address like 1024. So we go to address 1024 and we see the character C. And then it would be followed by A and T. So, okay, so in that first example, str is actually assigned a memory address. Okay, the next example, null is actually just like a placeholder. We're assigning the variable, the object variable of value, but it has no, but it's not, but it doesn't refer to an address in memory. Okay, so, but it actually, you know, your code would actually run. I mean, that's actually not a compiler error. Well, none of this is a compiler error. Okay, and then the third example, y is not assigned a value. So the first example, str is actually assigned an address. X is assigned a value, but no address. Y is not assigned a value at all. Okay, so now let's see what happens here if we try to run this code. Okay, so again, S is assigned, given an address. T is just assigned no address. And Y has no value. So let's say we want to take the length of all, so they're all string variables. Let's say we want to find the length. The first example, like len S, would be assigned 3. We can go s.length. Well, S is assigned cat. It has 3 characters. That's no problem. Now look at that middle one, t.length. T is assigned the value null. And when you go null dot anything, you're going to, that's what's called a null pointer exception. And I'm sure we've all seen them. Just like we've all seen array index out of bounds exception. But it's not a compiler error. So in other words, if you typed in, you know, len t as t.length, you wouldn't get a red dot. But when you run it, you actually, that's when the problem arises. You know, the runtime environment is trying to find the number of characters in T, but T doesn't have a length because it doesn't really refer to a string in memory. But it's not a compiler error. But let's look at that very last one. We want to take y.length, but see how y has not been assigned a value. So, so when you go y.length, you actually, you'll get a red dot. It'll say it can't take the length of the string because y actually hasn't even been assigned a value. And in some ways that, you know, then you have to assign a y value to make the code work. So, okay, so that's the whole point of null. So null is just a placeholder. We can assign it to an object variable, and it just means that that object variable doesn't refer to anything. Okay, so writing methods that inspect an array for a specified property. So we're not going to use break or continue. We're only going to use one return statement. The other thing, students, we're going to minimize our iterations. So when I say there's 2 types of methods that we're going to write. One that checks if every element of array has a certain property. And the second version, if just one element of the array has this property. So let's just see here. Let's just look at an example here. So let's say so we're going to try and write this method, all lengths even. So we have what the input parameter is string arg, an array of strings, and we're going to look at the length of every string, and this method will return true if the length of every string is even. So let's say args of 0 is cat. Well, then it would return false because cat has 3 characters in it. So all it takes is all we need is just one array element to have an odd number of characters, and then the method returns false. But if every single array element has an even number of characters, the method returns true. Okay, so let's just look at the code here. And they're all pretty much the same. Basically, I'm teaching you an algorithm how to do this. Okay, so these methods that check if every element of an array has a certain property. So let's start by assuming every array has, that it's true. We're going to assume that every array element has the given property. And then what we're going to do is we're going to write a loop. And if we find that one array element doesn't have the property, we set flag to false. So we declare, first of all, the method, we look to the method name is all lengths even. And we look to the left. And what does it say? Boolean. That means that this method, it's a contract with the user. We're saying if you use this method, you'll get a Boolean value in return. You're either going to get true or false in return. And so the first thing that we do there, like on slide, I don't see a slide number. The first thing that we do there, declare a Boolean variable called flag. It's a pretty common name for a Boolean variable. And let's assign it true. Let's just assume that every method in this array has this given property. And then the last thing we do is return flag. There's your return statement. There's the only return statement right at the end. Okay. So then we write a while loop, and we're going to look at the array elements one by one. And if one array element has an odd number of characters, we stop the loop. If one array element has an odd number of characters, change flag to false and then stop the loop. Well, that will stop the loop when you change flag to false. Okay. Okay, so we're going to use a while loop in this case. So we have to declare the counter variable right before the loop. So I'll call the counter variable index. So we initialize it to 0. So we start with the very first element of the array. And then see, and this is what I think is kind of hard for students. So there's two reasons why I like this way of doing this. I think it's kind of, there's nothing, no reason why you have to write a method that only has one return. It's perfectly legitimate to write methods with more than one return. But the one thing I like about it is you only have one exit point from the method. So if you have more than one exit point, maybe it's a little bit harder to debug, or if you have multiple exit points. If the method's kind of long, you've got return all over the place. Maybe you think it's returning from the last return when it's actually, exiting from the first return. But in this case, there's only this method has to go all the way to the end, and because there's only one return. And the other thing I like about it, see in the while loop, the Boolean condition in the while loop, it's a compound Boolean expression. And I do think students have a hard time with compound Boolean expressions. And so basically, the compound Boolean expression tells you the two conditions under which this loop will stop. Either index is equal to args.length, right? That means we've looked at every single array element, or the flag is false. When flag is false, that means we found an array element that has an odd number of characters. Okay, so let's look at the very first line in the while loop. And so remember, you always start on the right side of an assignment operator. You see that thing that says like flag equals arg index.length. Just look at the right side. Okay, so the individual array element is arg index, and then dot length, that's the number of elements. So like arg index dot length parentheses is the number of characters in that array element, and then we find the remainder when when we divide by 2. And so that's either going to assign true to flag or false to flag. Okay, so if the remainder is 0, well, that means that the number of array elements, the number of characters is even. But if the number of elements is odd, flag will be assigned false. And then the next time you check the Boolean expression in the while loop, and false will stop the loop. And then you return false. Okay, if you go through, so flag never changes to false, what eventually is going to happen, index will equal args.length, meaning you've looked at every array element. Then once again, in that case, you return true. And you can see it's really short. There's not too many, if I don't count that the right braces, it's 1, 2, 3, 4, 5, 6 lines of code. And so again, basically, so for these for all methods, the one where you're checking, you want to see if every element of an array has a given property, start with flag equal to true. Okay. So any questions right now? And then I'm going to do one more example. Then we're going to open Eclipse. Hopefully it's not a problem with Eclipse. Okay, so here's the second example. In this case, this is an exist. We just want to know just one element of that array arg equal to str. That's all we need is just one value. So let's say like str was cat. If one array element is equal to cat, then we return true and stop. Okay, so my cat is joining us. She probably thinks it's her dinner time, which it isn't. Okay. Okay, so I may have to lock her out of the room. Okay, let's see what happens. Okay. So let's just look at this example. This one's slightly trickier. But okay. So when we want an exist, we want to see if just one. All we want to know is there one element of the array that satisfies the given property? Well, we're going to assume that no element of the array satisfies the given property, and then we're going to loop through the array, and so we're going to assume that no element has a given property and we're going to set flag to false. So we'll initialize flag to false. We'll loop through the array, and if one element has a given property, we set flag to true, and then we stop the loop. So notice how, in this case, instead of index less than args dot length, but instead of and flag, it's and not flag. Remember the not operator? It turns true. It basically, it turns true to false and false to true. So a flag, so the first time flag is false, so not false is true. So so once flag gets, so in this case, we want to know, is an array element equal to str? So again, we so the first statement, flag is assigned arg index dot equals str. So if the latest array element is not equal to str, flag stays false. But if arg index is equal to str, flag will come true, and then the next time you check the Boolean expression, not true is false, and you stop the loop. Once again, it's not a lot of code. And again, so for the if we're just checking if one element of the array has a given property, you set flag to false, and then instead of flat, and the Boolean expression will have not flag instead of flat. Okay, I'm gonna put her in the other room. Hold on, sorry about the interruption. She's not registered for the course, so. No, you gotta. So we'll see how this works. Sometimes she starts crying really loud. Okay, so I always tell you, I can take you back to the Humane Society, but I'm not sure she knows what I'm talking about. I would never do that. I'm just joking. She's a great cat. Okay, so students, any questions? And is there anything else I want to say? Oh, so let's look at what we're not going to do. I'll remind you of this in your assignments. So we're not going to use a break statement. So what I see a lot of students doing is, oh, they find, let's say like the all lengths even. They find a length that's not even, and they set flag to false, and then they break. And that's how they get out of the loop. So we're not going to get out of a loop with the break statement. Since you'll see books that say never use break, like in an academic setting, all your teacher will tell you not to use break. Okay, the Java code has break all over it. Like if you actually look at the code for a lot of these classes that come with the Java development kit, there really is a lot of use of break. But the one thing that whoever wrote it did a lot of testing, did a lot of unit testing. And so, I can't say, you're kind of discouraged in academics not to use break, but I think there's a lot of programmers who actually do use break. What don't I like about this? Oh, so students, some students would try to get out of a loop by saying, well, don't use break. So they would change the counter variable in the loop. See in the loop, I go, if the index is odd, you set flag to false, and I go index is assigned arg.length. So you don't want to change that. I think that's really bad. That's hard to find. I think that's much worse than break. Don't change the counter variable inside your loop. That's a little confusing. The only place where your counter variables should change in a for loop is actually in the for loop header. You don't want it changing in two places. I think that leads to lots of debugging problems. And we're not going to have multiple returns. So, and there's nothing wrong with multiple returns. I see it in books all over the place. So in this example, if we find a length that's odd, we return false. And if we actually get through the entire loop and find that all the array lengths are even, we return true. But we're not going to do that. So any questions, students, before I stop sharing? Okay, so I'm hoping, okay, stop sharing. Okay, so let's see what happens. Oh, shoot. I don't know what happened to my cursor. So this is kind of sad. So let's see how I'm going to share. I want to share, let's see here. See if I can do this with my, now that I don't have a cursor, or maybe I can do it with this pen here. Okay, so I'm going to share the screen. Does that work? Yes, I'm going to share the screen, and I'm going to share Eclipse. Okay, so the one thing I see, this might be a problem here. Okay, so this is definitely a problem, students. I might have to shoot. It's not letting me type. So Shoot. So let's see, what can I do here? I think I might have to, the unfortunate thing is, the only way I know how to do this, I think I'm gonna stop the recording. And if you give me like a 2 or 3 minute break, I will just take, you're not required to come back. I'm not gonna be insulted if you don't come back. I need to take a 5-minute break and reboot my computer. So just because of my cursor is lost. So I'm gonna come back and I'll restart Zoom in about 5 minutes because I can't type anything. Oh, wait, no, I can, all right. Okay, why didn't that work before? Okay, so students, crisis averted. Okay, so let's ask, I forgot who asked the question, something about wrapper classes and wrapper classes. So there's no string class it's kind of like a wrapper class. This is what I mean by wrapper class. So the primitive types are all the variable types that start with the, so I'm typing actually in, oh, my cursor's back, what happened? So maybe the computer knew I was going to turn it off and decided to cooperate with me. Okay, so what kind of teacher is this? Okay, so when you first learn Java, the first thing you learn about the primitive data types, like, and all the primitive data types are like int, x equals, let's say like 9. Okay, and primitive data types are always, first of all, they're keywords, like int is a keyword, and meaning we can't use it as a variable name. And they're always lowercase. The primitive data types are always spelled lowercase characters. And so what's actually stored, X is a variable, and it's reserved memory we reserve memory for X in the computer's memory. And what's actually stored at the computer, what's actually stored in this memory for X is 9. It's the actual value itself. Okay, now there's this primitive, there's what's called the wrapper class, and I'm going to, let's say, I'm also going to assign it 9. So this is an object. And so this is a primitive type. And this is what's called a wrapper class. So all these primitive types have a corresponding wrapper class. So there's 8 primitive types, and I think there are 8 I think there are 8 wrapper classes. I'm pretty sure there are 8 wrapper classes. The ones integer and double are the ones that are used the most, I think, in character. So they're useful for array lists if you want to store, a collection of integers. Array lists have to be collections of object types, not primitive types. So you need the wrapper classes for array lists for one. But again, since the wrapper class is an object, what's actually stored in 9 is an address. So maybe y, like on line 34, variable y is assigned to address 2048. And you go to address 2048 and you'll see the 9 there. Okay, whereas in line 34, x is not assigned an address. X is actually, if you actually go to the memory location for x, you'll actually see the 9. So, so wrapper classes, they don't really use them a lot. They're good for array lists. They have what are called static methods. You can convert strings to integers, stuff like that. So hopefully that answered the question about, maybe I said more than you ever wanted to know about wrapper classes. But yeah, but when you see
That answered my question.
Oh, I did?
Mm-hmm.
Oh, okay, great. Okay. So when you see a variable type that starts with uppercase, that's an object. And the one last thing I'll say, since the compiler doesn't enforce that rule. So that's kind of the primitive types definitely do start with lowercase, and the compiler will enforce it. But we can define classes that start with a lowercase character. It just, it's kind of, it looks bad, right? No one, people, what is wrong with this person? Classes are supposed to start with uppercase. It's kind of like, it's good manners that when you write a class that you start the class name with an uppercase character, because then we can immediately identify that data type as a class. So, okay. So why don't I continue here? So let's actually write these 2 methods, and then we'll just write this code. So let's start, basically both methods there. And actually I put the code online, the complete solution. But we're going to write 2 methods. And so we're going to determine if every element of array is greater than 100 or less than 10. So we're going to have a couple of compound Boolean expressions here. And so, or if at least, and then the second version is it contains, all we need is one value to be greater than 100 or less than 10 to be true. So in the first case, we want to know, is every value greater than 100 or less than 10? And if you look at that, like on line 37, if you pass an AR of X, every element of the array has that property. Every element is greater than 100 or less than 10. Whereas in the second example, but then when we change AR of X, we'll change the third element to 11, and then at least one element won't have that property. So if you executed lines 38 and 40, it should be true, false. So let's just try this. Okay, so let's just try writing it. Right now, again, you get see, you have a compiler error, you have a red dot, because we're not returning, it says this method is going to return a Boolean value. Right now, we're not returning anything. So, I need to get a new lamp. So I'm not going to put comments in. So this is a for all. We want to know if every element of the array has the given condition. So we'll just start with, we're going to assume that the answer is true. So we'll say, we'll declare a Boolean variable and set flag to true, and then we'll just go return flag. And now the code compiles. And it doesn't, it always returns true. It's not very useful, but it does compile. Okay, so now what we have to do is we have to write a loop that assigns flag false if we encounter a value that's between, from, less than 100 and greater than, less than or equal to 100 and greater or equal to 10. Okay, so we're going to have a count, we're going to write we're going to write a while loop. So we have to assign the count, we have to declare the counter variable outside the loop. And now we have our famous while loop, while index, and what's the name of the array? X. So while the index, it starts at 0 and while it's less than the length of the array, and then it's an and condition, and while flag is still true. So the first time it's guaranteed to go through because we'll assume that the array has at least one element. So 0 is less than the length of the array and flag is true. We defined it to be true. So now we want to know, do we want, and then how are we going to, so every time we inspect an array element, we're going to assign a new element to flag. Okay, so flag is assigned, I'm going to put in parentheses even though we don't need to do it. So I'm going to evaluate the expression. So we're going to check to see what's the name of the array? So is X index, I messed this up in the last class, okay, greater than 100, and then we need OR, the double pipe is the OR, X index, this is what I messed up last time, less than 10. Good, there's no compiler error. Okay, so OR means one of the Boolean for the Boolean expression to be true, at least one of the individual Boolean expressions has to be true. And it's been possible for them both to be true at the same time. A number can't be greater than 100 and less than 10 at the same time. So if the number is greater than 100, if the array element is greater than 100, it's going to be true. If the array element is less than 10, it's going to be assigned true. But if let's say it's 50, 50 is not greater than 100, and 50 is not less than 10. In that case, you'd have false or false. And so if X index is 50, flag would be assigned false. And the next time you check the Boolean expression in the while loop, it's going to be index less than X dot length and false. Your loop will stop. And of course, we want to avoid infinite loops, so we'll do that. And that's all there is. So if I don't count the right braces, it's, the header, it's 4, 5, 6, 7 lines of code. And basically, I'm showing you an algorithm. If it's a for all problem, just set the flag to true, and the Boolean expression is you check the index and flag. And then you have to, then perhaps reset flag, and then check to see if the latest array element has the given condition. Okay, so let's do the next one here. Okay, so students, in this case, we want to know if at least one element, all we need is one. It's not everyone, but just one. I wonder if I can expand this here. I'm not sure what they did for me. Okay, so let's like here, okay, so like in the first example, okay, let's look at line 48 in the code. none of them satisfy the property. 88's, not greater than 100 or less than 10. Not one of those values in line 48 satisfies the property. So in that case, contains greater than 100 or less than 10 would be false. All you need is just one value. And that's what I do on line 50. I change the first array element to 458. Now we have one value that satisfies the property, so then it will be true. Okay, so we're going to assume for the existence or just one, let's just assume that not one element satisfies that property. So we'll just say Boolean flag is now false. And then we're going to write a loop that'll change flag to true if we find one element that satisfies the property. Of course, similar. And here, this is the one that's a little bit different. Index less than x dot length. And in this case, it's and not flag. So students, if you went and flag, it would never loop, right? Because you're setting flag to false. We'll try that in a second. And since the rest is the same, so I will just copy. So I'm doing what you're not supposed to do is copy and paste. So what I just did is kind of discouraged. I do it all the time. So don't do it. Do as I say, don't do as I do. Everybody does it. It can lead to errors, copying and pasting. So I say, just type the code instead of copying and pasting. Then we have to return flag. Okay, so look, so in this case, we're going to check to see is the latest array element greater than 100 or less than 10? In that case, flag would be set to true, and then the next time you check the Boolean condition, not true is false. So if flag gets set to true, the while loop stops automatically. So again, both cases, once we know the answer, once we're guaranteed of the answer, let's just stop the loop. Okay, so let's actually run this code. Okay, and so we'll run the code. And so the first case, I don't know if you can see that. I guess is this in the way? Okay, so yeah, the first case, it should be true, false, right? First case, they all satisfy the property. The second, then we change AR3 to 11, so at least one value doesn't satisfy the property. So then for the second method, none of them satisfy the property, so it should be false. And then we change it so that at least one element satisfies the property. So either one element is less than 10 or one element is greater than 100. So I think it's true, false, false, true, true. We'll see. True, false, false, true, true. Okay, and I have the code online, so you don't have to retype it. Why is this? Okay, so let me close this. Let me just show you one thing here, students, and I'll stop. Then I'm gonna stop sharing. So right here, this is a common error. The contains one, does at least one element of this array have a given value. So students started at false, and they forget, instead of going and not flag, they go and flag. Well, let's just let's think about what's happening here. What you're saying here, this is the equivalent of going index less than x dot length and false. It's immediately false. And false is always false. So remember, an and condition, both sides of the and have to be true for the whole thing to be true. If just one side is false, then the whole thing is false. So it's like, I think if we're talking, sometimes students have a hard time with or and, but in everyday life, we don't. Like if I said to you, today's Monday and today is Tuesday, I think you would know that that's false because it can't be both. But if I said today's Monday or today's Tuesday, I think you would intuitively know that that's true. It's just the difference if I said do problems 1 or 3 or do problems 1 and 3, you know the difference. Okay? So, but sometimes when we see this in computer code, we stop using our common sense or something. But that's all it means, right? So like that line 36, you said, again, this is the contains. We just want to know if one value it has the given property. We start flag at false. And if we forget to put that not in front of flag, it's always going to return false. So I think the last 3 lines should be false, false, false. This method returns false, always. The second one, because of that change I made. Let's just try this, see if I know what I'm talking about. But sometimes I do, sometimes I don't. Yeah, false, false, false. So that's just a common error. Yeah, that's the common errors right here. So unless there are any questions, I'm going to stop sharing. I'm going to stop sharing. I might stop the recording as well. So now I'm going to stop the recording.